Okay, let's look at another example here. What about this question? It's asking what's the longest wavelength of a photon that can be emitted from a hydrogen atom in which a final state is n equals 9. And of course we got our Rydberg constant there. So what do we know? We know that E equals hc over lambda. We know that E is hc over lambda. And so the longest wavelength is going to have the least energy because these are inverse, right? So it's asking about the longest wavelength. So that means that this lambda is going to be really big, which means this E is going to be really small. So if we're looking at n equals 9, then we can, that energy drawing, we know that if this is n equals 9, then the energy, the lowest energy, is either going to be from 8 to 9 or from 9 to 10. So let's look at our equation where we have hc lambda, or hc over lambda, is equal to hcr times our 1 over n initial squared minus 1 over n sub final squared. And we do these calculations between 8 and 9 and between 9 and 10, and we see which one gives the longest answer. So let's look at that. If we were to cross cancel these, make it a little easier, and flip this over, so what we end up, if we cross cancel, is we got 1 over lambda is equal to r times that 1 over n squared minus 1 over n sub final squared. And if we flip this, then we have to flip this, so that leads to lambda, our wavelength, which is what we're looking for, is basically 1 over r times our 1 over initial n squared minus the final n squared. Okay, so if we put some numbers in, let's do lambda from 8 to 9. Oops, sorry. Let me fix that. That's going to equal 1 over our r, which is 1.097 e to the 7th, times from 8 to 9, that's going to be 1 over 8 squared minus 1 over 9 squared. And when we do that calculation, we get 27,798 nanometers. And what do you know? That's going to be pretty close to one of our answer choices. However, do we know that that's the longest? We're not sure because we haven't compared, because we got to check and see if lambda 9 to 10, how that works. So let's do that same calculation, or that calculation with the same formula. So it's 1.097 e to the 7th times, in this case, it's 1 over, let's see, it would be, initial would be 10 squared minus the final, which is 9 squared. And we find that frequency to be 38,862 nanometers. And that is one of the answer choices, rounded to 39,000, and it is the larger of the two. So that's going to be the correct answer.